This is Josh White with JW Math Tutoring. Today's video is going to cover the Ultimate Desmos Guide to Digital ACT Math Core Skills. So let's go ahead and get right to it.
But life is a dream the calculus could never predict.
Before I start this ACT Math video, I just want to take a couple seconds and let you know about my Improve Your ACT Math Score course, available on both Udemy and Teachable. The course features a wide and comprehensive review of ACT math topics, including how to use both the TI-84 and Desmos graphing calculators. It also includes general strategies, such as back solving and picking numbers, and a review of topics in algebra, geometry, probability and statistics, and other miscellaneous topics as well. It includes over 10 hours of instructional videos and over 20 total hours of videos including solutions to various problems. So please check out that video if you're looking for more help on improving your ACT math score. Otherwise, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. And let's go ahead and get started with this video. This video is going to cover the core or basic skills that you should know in Desmos for the ACT math section. So a couple things I just want to mention before I begin. The address of the website that I'm using, which has the ACT version of Desmos, is going to be obviously linked in the description of the video, also in the pinned comment, and it'll be displayed on the screen as well at the bottom. Okay, another thing, the PDF guide, meaning basically the reference sheet, the thing that you see on the screen now. There'll be a link to that in the description of the video and also in the pinned comment of the video. And of course, just be aware that that could change slightly in appearance, or if I edit things or whatever, between the time this video is being recorded and when you're watching it. But you can always find a link to the most recent version, again, in the description or in the pinned comment. Same thing with the practice problems that I'm going to go through. So just to show you an example, this guide with the practice problems, this PDF file, again, linked to both in the description of the video and also in the pinned comment of the video. And the way this is going to work is I'm going to go through and talk about some of these various topics that you see there, demonstrate them, or some maybe just talk about them in the Desmos window on the right side of the screen. And then after that, go through a problem or sometimes several problems related to that topic. Okay, so that's the basic setup of this. And of course, there's going to be a lot of other videos that are part of this Ultimate Desmos Guide to Digital ACT Math. You basically have an explainer, which is the very first video talking about the general kind of setup of this playlist and everything. And then after that, there's an introduction to Desmos that covers basic Desmos skills and things to be aware of. So if you haven't watched that yet and you're not that familiar with Desmos, please go watch that video first, then come back to here, because there will be things in there that you are assumed to have known. Okay, so with all that being said, let's go ahead and get started. So the first thing I want to talk about is converting fractions to decimals, decimals to fractions, and back and forth, so on and so forth. So, okay, obviously you can type a fraction here, right, and it converts it to the decimal. And then if you click the button, right, it'll send it back to a fraction. So this little button is what what you're looking for. Now, you can also simplify fractions. So you have like 970 over 65. So notice it gives me the decimal equivalent, right? But then if I click it again, down here, notice it gives me the simplified version of the fraction. Okay? So be aware of that. Now, one thing I just want to mention. Say that you have a number. Okay, so for example, right here, say you have this number. Maybe like you're solving system equations or something, and like this is the x value of the coordinate, okay? And you type this. Notice when I click this, it gives me a random gigantic fraction. What is that? 133,333 over 100,000. Okay, that's not what this number is equivalent to, or it's not what it's supposed to be equivalent to. This is supposed to really be equal to 4/3. So notice what happens is, if you don't have enough decimal places for the repeating pattern, it's not going to recognize what the fraction is. Let me just unclick this. So for example, if I just had this, right? This is just giving me this random 5729 over that. However, if there are a lot more sixes here, notice first it disappears, then it comes back. Okay, see now it's giving me the actual fraction that, it's supposed to be equivalent to 55 over 24. So that's just one thing to be aware of in terms of fractions. It needs enough decimal places in order to recognize the pattern to send it to the correct fraction sometimes. And you can also do things with like mixed numbers. So what you have to do, make sure I do this correctly, with the mixed number is, then highlight this. There we go. Basically, it's like you have to type the whole number part first, then the numerator of the fraction, then highlight this, and then, since only 3's are highlighted, when I press the division sign, the forward slash, then it'll make the denominator, and right there you have 2 3/4. And then notice it can convert it back and forth to 11/4. Okay? So if you need to do anything with a mixed number, that's how you can go from mixed number to improper fraction. All right, let's next talk briefly about percentages. So you can type anything in with a percentage. So like, you can just type 67% of 200. You know what I mean? It'll just calculate right there. When you do the percent sign, it'll automatically put the of in. You can use these percentages in equations. You can use them in regression statements and so on and so forth. The whole point is you can just type the thing as a percentage. You don't need to convert it to a decimal. Okay? Next thing, let's talk about defining a number as a letter, okay, to basically carry it over as an exact value. So where this is really useful is you define something, you solve something, whatever. You get a value for something. And then you want to use that value in another calculation, okay? So the point is, so here, here's an example. I'm going to do the sine inverse of 3/5. Now, notice this is already, I believe, yes, it's already set up in degree mode. So it's giving me, so this angle that I'm looking at is 36.869 Bova degrees. Now, let's say for whatever reason, I wanted to find the cosine of the angle, okay? So, like, I do cosine. Normally, you would think, okay, well, I'm going to type out 36.869 8976458, all those decimals. But first of all, that takes way too much time. Second of all, it's not going to be exact. So what you want to do instead is you want to define this as some value. You can use a capital letter, you can use a lowercase letter, doesn't matter. So I'm going to define this as a, and then in the next line, when I want to do the cosine of that, I just type cosine a, okay? And then it gives me the answer, which is 0.8 or 4/5, because this is basically a 3, 4, 5 triangle that I've set up here. Okay, so the whole point is you don't need to retype the entire decimal with like rounding or truncating or all that stuff and potentially make an error. You just define any value as a number, or excuse me, as a letter, and then you use that letter like for any future calculations you need to do, and it does the exact value. Okay. All right, so now let's talk about sliders. So when I talk about adding sliders, really that's basically, any letter other than x and y where we're going to define it as a value, basically any constant. So if you type something, y equals 2x plus b here, notice it pops up. It says add a slider for b, right? So you can either click that, or you could just go down here and type b equals whatever. You can start with 1, you can start with 4, doesn't matter. Okay, click enter. And now, notice here you can move it, positive, negative, wherever. The default is -10 to 10, but you can adjust that. We just click on it, make the low range whatever we want. We can make the high range up here. So now it's -20 to +20. Notice the graph is shifting as I move this. And the other thing too, you can adjust the step. So the step is how much the value changes by for like each movement, of the mouse. So if you're only looking at, say, integer values, maybe you set the step to 1, so that way it's just jumping, what I'm saying, only between integers. You're not concerned with all the decimal values in between those. Okay? So that's the basics of a slider. And you can use this a lot of times like to move things, to potentially look for intersections, or to look for like the maximum or minimum value of something. All right. So those are kind of basic kind of things to be aware of. Now we'll actually start getting into some specific operations that you can use to solve problems. So the first one is the distance formula. So all you're going to do is you're going to type distance and then open parentheses, and then inside here you would put your 2 points. Now if you want to type the points themselves, you would separate them with a comma. Okay, and there's our distance right there. Or the method that I prefer to do is I prefer to define the points themselves using capital letters, and you can do this for points in addition to just numerical values like we just went over. You can also, by the way, label them if you're doing something with a graph and it's easy to see. So like here, this is point A, this is point B. Okay, and then in my distance formula, instead of typing out the entire thing, all the coordinates, I just do this. All right, and now it gives me the distance. The advantage to this is like if you're checking answer choices, you can just go easily change, one of the coordinates of point A, or maybe change one of the coordinates of point B, or whatever it is, rather than having to retype, the entire expression. All right, so now let's look at an example of a problem where you could use the distance formula to help solve it. All right, so we have this first problem here where you're given 2 points, you're told that they're on a line segment, and you're told that basically the ratio of A to B, that distance from, distance of line segment AB, or from A to B, is basically 1 to 4 compared to the distance of A to C. So in other words, AB to AC is in a ratio of 1 to 4. So which of the following are the coordinates of point C? All right, so here's how I would attack this one in Desmos. Let's first graph point A. We can label it. Then let's graph point B. We can label it. And then I'm going to find the distance from A to B. All right, so notice it works out to a nice even number. It's 5. So now what I'm going to do is I want the ratio of A distance from A to B to distance from A to C to be 1 to 4, 1/4. So what I'm going to do now is I'm going to divide them, and I'm just going to have to type in the answer choices for point C. So notice, first answer choice. And you can also just, first of all, like some of these you can eliminate if you actually graph them out and see that this is technically facing the wrong direction. But notice it doesn't give us the right answer. The ratio of the distances is 1 to 3. It's not 1 to 4. So that's wrong. Now let's check the next one. Okay, now we get 1.2, which I believe is 1 to 5. It's way up here, just a little bit off the screen. Okay, so that's not correct. Let's check this one next. Okay, that looks like it's way too close. Here you can see this distance. This is not like a nice fraction or anything. That's why there's no fraction available. But the point is it's not 1 to 4. It's not 0.25. So it looks like it's going to be the last one by process of elimination. But let's just confirm. And why did I should keep this C here, not change it to D, even though it's answer choice D. All right, so now we have a nice picture. Now the distance from A to B over A to C is 1 to 4. That matches the distance in the problem. Therefore, the correct answer for this problem is going to be letter D. And this is how you could use the distance formula to solve it. All right, so now that we've done that, let's talk about one other thing, and I don't have a demonstration problem for this, but it's the midpoint formula. So you can use the midpoint formula the exact same way that you use the distance formula. You can type in the 2 points, and it'll show you where the midpoint is. If you want to click it, it'll show the coordinates on the graph, but if not, the coordinates are just listed here. So either way is fine. And then you can also do the same thing where you define the points using A or B, and it'll find the midpoint between them. So it's fairly straight, and you can just type, midpoint parentheses here, A comma B, and I could just say A is, whatever random point, and B is another random point, and there's the midpoint. Basically, let's take this off so it's a little easier to see visually. There's the midpoint halfway between my 2 points A and B. Okay, so very similar to the distance formula. One other thing that you can use these for as well, and I'll just demonstrate this briefly, even though I don't have an example problem for it because it's not a common problem type, is you can graph a circle. So if you have the equation of a circle, say it's given and it is not in standard form, you can graph it, and then we can take this point. We can take these max and min values right here. I'm going to call this top one. Wait, hold on, I didn't do this correctly. This is supposed to be a y there. So sorry, this clears out. That was not supposed to be. So we have this, and we have this. These are the points I want. Okay, so now, let's call this A. Let's call this B. And what you can do is you can say, okay, the distance between A and B, that's the diameter of the circle, and technically, if we wanted the radius, we would just divide that by 2. Okay, so there's the radius of the circle, let's see, and it's whatever, some random fraction, but we don't really care about that. And if you want to find the center of the circle, you could just find the midpoint between these 2 points as well. Okay, so right there it is, -1, 3. Clearly is the center of the circle. So that's one of their use. I don't have a specific problem on that because that doesn't come up very much in the ACT. It comes up a lot more in the SAT. But just to be aware, that's another instance where you can use those functions. All right, so now let's talk about mean, median, and standard deviation. So when you have a small list of data, you can find the mean or the median or the standard deviation of that data by just typing it in. Okay, so you can just type, whatever, mean of 1. Doesn't need to be in any specific order. There's just a bunch of random numbers. There's the mean of that expression. Here's the median of this. Technically, if you put these in ascending order, you would see that 3 and 4 are your 2 middle values because there's an even number, so it averages them, and that's how it gets 3.5. And then you could also do standard deviation. Note, for standard deviation, I believe you should use STDEVP, standard deviation of a population. At least that's the version that the SAT has used in their problems. We were actually calculating standard deviation as compared to this. This is standard deviation of a sample. I believe you want to use standard deviation of a population. But in any case, so you can just type this out. But again, these only apply to when you're given a list of numbers. Like, this is not for when data is presented in a frequency table, and you do have to type out all of the values. All right, so now let's look at a problem, an example problem where we can use these. So problem number 2 here. We have a data set, okay, 7 numbers between 10 and 25. And then we have another data set, which is 7 numbers plus the number 40, which the following compares the mean and median of the data sets. So let's say data set A is equal to, and actually what I'm going to do is I'm going to show you another trick you can use here. So this is defining, basically I'm going to define a list. So 10, 12, 18, 19, 21, 24, 25. Okay, so I have 7 elements in there. Let me copy this. And then let's do, now I'm going to turn it in, for set B, I'm going to take this, it's the same 7 numbers, so I'm going to add 40. Okay. Scroll over. All right. So now what I'm going to do, I'm going to compare the mean of A. Now I don't have to retype all the numbers. And I'm going to compare the mean of B. Okay, so notice the mean of B clearly has gone up. And if you think about this theoretically, B has the same exact numbers as A, except you're adding a number, 40, which is larger than the existing mean. Like the existing mean, which you can see here for A, has to be between 10 and 25. So when you add 40 to it, that's going to pull the average up. Okay, so the mean of B will definitely be greater than the mean of A. So if you're going through, you know, kind of like process of elimination, all right, we can get rid of this. All right, so if you're going through process of elimination, looking at the answers, you know, we can get rid of D away, and we can get rid of C. We know that they're not going to be equal. We keep A and B for right now. In A, the mean of B is greater than the mean of A. Yep, that's what we found. And in B, the mean of B is greater than mean. Okay, the question is now, what happens to the medians? So let's compare the medians and see what happens. So here it looks like the median of B is greater than the median of A. But does that have to remain the case? So like the way I would check that is, okay, if the median is 19, let's make the numbers around this all 19. Okay, so now they're still identical. So notice what happens here. It is possible that the median does not change. Okay? 19 in the first one, 19 in the second one. Basically, adding an outlier value doesn't affect that. And you could, you know, even do this to the extreme. You could make every single value the same number and then just add a 40 to it. Okay? And in both of them. So therefore, it would be easy to see that the median is the same. The median does not change in both. So basically, the correct answer for this one is going to be letter B. We cannot determine what will happen to the median. Basically, it could be greater or it could be equal. We don't know. So therefore, that's the correct answer would be letter B. Median cannot be determined. Next, let's look at standard deviation of a data set and a problem involving that. So here, you are given 4 data sets. They're relatively small. If you understand standard deviation, I mean, you can probably just look at this and figure out what the answer is going to be right away off, you know, without doing any work, and that's fine. But I just want to show you that technically, you can do it in Desmos as well. So here's the standard deviation of the first one. I'm just going to copy this down, and then I'm going to change the values here to... So notice what happened. The standard deviation went down a lot when I went from the first one to the second one. Notice it went down even more when I went to answer choice C, and now we go to the last one. Notice here it's technically 0. So which one of these has the smallest standard deviation? It's answer choice D. Of course, it's because all of them are the same number, same, you know, basically the mean and the median are the same. Therefore, in fact, all the values are the same. Therefore, standard deviation is 0. So again, if you understand standard deviation and know what that concept is, then you could probably just look at this problem and figure it out. But I still just wanted to demonstrate that you can use Desmos to calculate it as well. All right, now let's talk about least common multiple and greatest common factor, LCM and GCF. So these are just kind of two basic functions where you would type in either LCM and then put your two numbers inside parentheses separated by a comma, or GCF, your two numbers separated by a comma. And of course, you can use more than two numbers for the operations, as well. All right, obviously it's not going to change anything for these. I just added a 30, but like for LCM, just whatever, I add a 30 here. Notice it does change it. Okay, so that's the basics of how those are used. Now we'll look at an example problem. So here's a problem, the bottom of page 4, dealing with least common multiple. Basically, you have two runners that are starting a race, at the same exact time, same exact position, and one is doing laps in 30 seconds, one's doing in 25 seconds, and basically wants to know, like, okay, once they start, after how much time will they both, like, be at the starting line again at the same time? It's like one is running faster than the other. Basically, it's like, how long does it take for one to completely catch up, one full lap to the other one? So this problem is really just asking for the least common multiple between 25 and 30. Because if you think about it, one of the laps is going to be like, the one person's laps are going to be like, start at 0, then 25, then 50, then 75, then 100, then 125, then 150, blah, blah, blah. And the other's going to be 30, 60, 90, 120, blah, blah. And you're going to see when do they first reach the same time. So you just basically type it in, and right here, LCM 25, 30, it's just 150, and that's it. Okay, so that's how you could solve this problem. All right, next up we have finding the remainder of long division of two numbers. And I'm just going to scroll up here so it's a little bit higher on the screen. So the way you do this is you use the mod function. So you type mod and then you put the larger number first and the smaller number second, meaning like if you think about a fraction form for division, it would be the numerator first and the denominator second. Okay, this is very useful. So like say 321 divided by 4. The remainder for that is basically 1. Okay, doesn't tell you how many times it goes into it, but it tells you solely what the remainder is. As I was saying, this is very useful for repeating pattern or repeating sequence problems, or also simplifying powers of I problems. Okay, so now let's take a look at an example problem. We're at the top of page 2 of the guide here. So you are given this repeating decimal. Okay, it's 0.2961. So 2961, 2961, whatever, goes on forever. It wants to know what is the value in the 326th digit after the decimal place. Okay, so if you wrote this out, you wrote out 326 digits, what number would you be on? What number would you end on? The easy way to do these problems is take the specific digit place we're looking for, meaning like the 326th thing, and we're going to divide it by the number of items in the repeating pattern. Okay, in this case there are 4. It could be, 3, could be 5, could be who knows how many, could be 7 if you're doing like a days in a week type thing. But in this case there's 4, there's 2961, so I'm going to divide it by 4. Then I look at the remainder. Okay, the remainder tells me what position in the pattern I am in. So for example, the remainder here is 2. That means I'm going to be at the second position in the pattern. Therefore, the correct answer is going to be letter B, 9. Now, if the remainder was 3, then I would be at the third position in the pattern. And just to show an example, for example, if I made it the 327th digit, okay, the remainder is 3, 327th digit is going to be a 6. Now, one thing just to be aware of, if I wanted the 328th digit, okay, so now I've like gone 2 more places forward, notice the remainder is not 4, the remainder is technically 0, okay? So for these repeating pattern, repeating sequence problems, the remainder for the last position in the pattern, whether it's like whether there's 4 things or 7 things or 8 things or whatever, the remainders are basically going to go like 1, 2, 3, 4, 5, 6, blah, 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 and then the last one will always be 0. It won't be the number of, say, it won't be a 4 or it won't be a 7 if there's 7 things, because technically if that's the remainder, well, the number could go in one more full time. So the remainders are always going to go 1, 2, 3, 4, blah, 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 0. So if you get a 0, that means you are at the last item, digit, whatever, in the pattern. All right, next let's talk about just solving systems of equations by graphing, or you could also see a problem where you're identifying the number of solutions to a system of equations. So it's fairly straightforward. You just graph both lines, graph both equations, and then you look for the intersection points. They're going to be highlighted. Of course, if the two lines are parallel, then there's no solution, or if there's no intersections, there are no solution. If one is not a line, if it's like a line in a quadratic or something. Um, if you see only one line on the graph, meaning it's the same line overlapping itself, then it's infinite solutions or all real numbers. Okay, so let's just look at a basic example problem. So here's a system of equations. What is the value of y for this? So all we have to do is go ahead, graph both lines. Okay, so they intersect right here. Notice it's a highlighted point. So what is the value of y for this? So it's just -2. Correct answer is going to be letter A. And that's it. Don't have to solve this out by hand. You don't have to, do anything else. You just graph them, find the intersection point, and then just make sure that you're answering, the correct coordinate, whether they're asking for x or y. All right, last thing at the bottom of the first page here. Let's look at complex number operations. So you can do any operations with complex numbers. The first thing you need to be aware of, and this was mentioned in my introduction video, is you need to make sure that Desmos is set to complex mode. I mean, very similar to what you have to do to a TI. You have to switch it from real numbers to complex number mode. So you turn this on, and then we can just do whatever operation we want. You can type I, like I squared. You can type I to a power, I to the 210th power, 211th power, 212th power, whatever it is. It'll give you the answer. And you can do various other operations, just multiplying things by each other. So 2i squared, this is really 2i squared, which is just equivalent to -2. Okay, so now let's look at an example problem, and I'm just going to go ahead and zoom in here just so that we can easily see the problem and the answers. So all I'm going to have to do is type the problem, and it gives me basically the answer. The problem is I don't know, there's no fraction button. There's no way to easily convert these to fractions. So what you have to do here is a little process of elimination to figure out which answer is going to be the correct one. First thing I would notice is the I term here is positive. Okay, so that means this is out and this is out. Okay, so we're down to basically these two choices. So now all we have to check is one of the numbers and see if it matches. If it matches, then that's the correct answer. If it doesn't match, then it's not the correct answer. So for example, in B, I'm going to first check the 20 over 29. Okay, that is 0.689655517. Notice that that looks very similar to this number in the front. That should be the correct answer. Whereas in D, if I do 20 over 21, okay, that doesn't match. That's not the correct answer. So the correct answer is going to be here, letter B. However, you could also check D as well. Or sorry, you could also check the I coefficient as well, meaning 8 over 29.2758620. Okay, notice it matches the same coefficient we have for the I term here. Okay, so if these work out to nice whole numbers or nice, easy, recognizable fractions, then you wouldn't have to do this work. But if they do not like this, you might have to take a little bit of extra time just to confirm which answer matches or which answer is equivalent. Now let's go ahead and continue with the top of the second page of core skills. So the first thing that's listed here is linear regression. Really what this is the idea of finding the slope or y-intercept or overall equation of a line either given 2 points on the line or given a point and slope or graph of the line. Okay? What you're going to do here is you're going to create a table. Then in the table, you're going to enter in values under the x1 and y1 columns. So either 1 point if you're given 1 point or 2 points if you're given 2. And then you're either going to type a regression statement or you're going to click the regression button. And linear regression will be the first available option that you see there. Now, a couple things to be aware of. For this regression statement, you use a tilde and not an equal sign. Second, if you know the slope of the line, and you're say you're only given 1 point, so really you're trying to figure out the y-intercept, then what you're going to do is you're going to enter that value in the regression statement. So you cannot use the regression button in that format. You have to enter it in manually. Okay? The regression button needs at least 2 points before it'll show up, and you only have 1 point. All right, so let's look at some example problems of how you could use this. So if we look at problem number 8 here, all the way at the bottom, okay, this line is given with a slope of -1/2, and you are told that it passes through this given point 3, 8. What's the equation of that line? Okay, so all we're going to do is first click the plus sign here to add a table. I'm going to type in the two coordinate values for the point, 3 and 8. And then now, again, you have to type the regression statement manually because we only have 1 point. If you would type a second point, then the regression button shows up, okay? But without that second point, you don't have it. So it's going to be y1, then tilde. Now, I already know the slope, so I'm not going to type mx1. I'm going to type the slope and then x1 and then plus b. Here is the equation of the line. Y equals -1/2 x plus b. B is 9.5. Now notice, if you look at the answers here, there's no decimals. They're all done in fractions, but it has to be answer choice B. And you could also just confirm that if you type B here and click the fraction button, we get 19/2. Okay, so correct answer, -1/2 x plus 19/2. Now, a couple things just to be aware of too. First, notice it has given us the graph of this line as well. So if you wanted other information, like for example the x-intercept, oh, it's right here. X-intercept is at 19. Or if you wanted to find another point on the line, which this will come up later, you could also graph that value, either a horizontal or vertical line, and then find the intersection point for its corresponding coordinate. Now, let's go to the top of the next page. Let me just clear this out. Here you're given 2 points, okay? 0, 4 and 1, 6, and it just wants to know what's the slope of the line that passes through those 2 points. So we can just add a table, type in the 2 points. Now you can just click the linear regression button and you can see what's the slope of this line. It's +2. Correct answer is going to be letter C, and that's it. Now just be aware that when you use the regression function, like the values are not stored in M and B like they were in the last example. So like remember how in the last example I typed B and then I was able to convert it to a fraction? If you try to do that here, if you try to type B, notice nothing happens. If you try it's not carrying over 4. If you try to type M, nothing happens, right? It's not carrying over 2. If you want to carry the values over, what you have to do is you have to click here and click this. And now it basically shows what I typed, what I was typing on the last problem. And now M is stored as 2 and B is stored as 4. Okay, so let's go back to the guide now. Let's talk about evaluating functions, either a single function or a combination of functions, or really this is the idea of given this specific x value, find the y value that's associated with that. So there's multiple ways you could do this. Quickest, easiest way, is you just type out the function. And then you just do f of whatever you want to find. F of 3, f of -4, f of 7, so on and so forth. Okay, so that's one way to do it. Another way is you can type out the function, and then you can go up here and click the create table thing, and it'll auto create a table and it'll fill in values for x and then show you the corresponding y or f of x. But you can also type your own values too. 10, 11, 12, 35, 210, whatever it is. You can just type them in here, it auto updates. So that's another way to do it. A third way you can technically do it is you can say graph x equals whatever the number is, which is a vertical line, and then it will you'll look for the intersection point and specifically the y coordinate of it. So for example, f of 3 is equal to -4, or x equals 8. See, now this is one of the problems with using this method. You have to go all the way up here. Okay, it's equal to 81. So of these methods, I would say the first one is my preferred method. The second one is useful if you have a number of values to evaluate, like you need to evaluate like 4 or 5 different numbers. You can just type them all in and see the answers right away. Method 3 is very useful if you do a regression to find a function, whether it's a line or a quadratic or whatever. So you do the regression, and then it'll display the graph when it does that, and then you want to evaluate or find some point on that graph. So you can just then type x equals whatever and look for the intersection point, rather than having to retype the function after the regression and then do the f of whatever, f of 3, f of 8, f of whatever you're looking for. The only problem that I just mentioned with 3 is if the number is very large, you might have to zoom in or zoom out a lot or do a lot of scrolling, okay, which you would not have to do with the other two methods. Also related to this, you can of course evaluate combinations of functions. So you can just type in two functions, f of x and say g of x, and then just do whatever, f of 2 minus g of 1, or f of 2 times g of 1. Or you can also do composition of functions as well. All right, so now let's go back to the practice problems. Let's look at example number 10 here. We're just going to do a basic evaluation of functions. Okay, we want to find f of -5. So I just type the original function itself. I do f of -5. It's -66. That's my answer. Correct answer for this one is letter C. Now, let's look at number 11. So I already have the first function f of x typed in. I'm going to now do the second function. Now I'm going to evaluate 2 times f of 4 minus g of -4. And when I do this all out, notice I get -11. So my answer for this one would just be letter D. And that's it. That's all you have to type for evaluating a combination of functions. You don't have to do order of operations or anything. You just type function 1, type function 2, then type out the statement that you're evaluating. Now, for problem number 12 at the bottom, here we have the same two functions, f of x and g of x, but we're going to do a composition of functions. So for example, if you want to find f of g of 2, okay, we get -6 as our answer, and that's it. No more work is needed. And we could confirm this, so for example, g of 2 is equal to -1. Okay, so now what is f of, that's what I'm plugging into f, -1. Okay, it's -6. Yep, we've got the correct answer, and that's it. That's all the work. Desmos will do the entire problem for you. All right, so let's now go back to the guide. Okay, so one other thing I mentioned earlier is finding a value of a function for a given x value of a function for a given y value. So this is basically a problem where it gives you what the function is equal to, or it gives you the y value. It wants to know what is the x when this happens, essentially. So one easy method to do this type of problem is to just graph y equals whatever the number is and look for the intersection point, specifically the x-coordinate from it. And this is useful because the intersection point will be clickable, and it's a lot easier than just tracing along the graph sometimes. Okay? So let's look at one example problem to show how you could do that. So we're at the top of the third page. Okay, so we have this quadratic, and it wants to know, okay, for what x value does, or for what positive x value does it equal 15? So all you got to do is just y equals 15. Now I'll have to scroll out a little bit here. Notice there's two intersection points, but it wants the positive one. So right here, it's at 2, 15. The x value is 2. Correct answer for this one is letter B. Okay, and that's it. That's all you have to do. Next, let's talk about solving equations. So there are many different types of equations that you can solve in Desmos quite easily. You have your basic linear equations, you have absolute value equations, you have radical equations, rational equations. There are quadratics, obviously. You have exponential equations, you have logarithmic equations. There are three common methods that you can use. I'm going to talk about each of them briefly and list the advantages and disadvantages, and then we'll look at some example problems. So the first method is, and this is actually the method that I generally prefer, you graph y equals the left side of the equation, y equals the right side of the equation, and then you look for the intersection point or points, and those are your solutions, specifically the x-coordinates. Okay? The reason I like this is because if it happens to be no solution or infinite solutions, then you're going to see like the same graph on top of itself if it's infinite, or if it's no solution, you're not going to see them intersecting, whether it's two parallel lines or just, two other graphs that never intersect. So that's the first method. The second method is you can just type the equation in as written and look for vertical lines. The problem or the issue with this is that for certain types of equations, usually radical equations, rational equations where there's an x in a denominator, and sometimes absolute value ones, the lines will not be clickable. So if they are not, so if you can't click on them and they're not on a whole number, it's difficult to determine what the exact value or solution of the problem is. A third method you can use is regression, and we'll show you how to do that. The problems with so regression is very useful because it will give you the exact value. So if you need to use the value for another calculation, then you can just carry it over. However, the problem with regression is it will only return one solution. So some questions might have two solutions or more, and therefore you might have to use restrictions or other things in order to get the other solution to the problem. All right, so let's look at some problems now, and I'll show you the various methods. Okay, so now let's take a look at this first example problem, number 14. I'm going to use method 1 first, which is graphing y equals left side, y equals right side. And then I'm going to look for the intersection between these two graphs. So I have to scroll a little bit. It looks like it's right here. It's at 2, 21. So we want the x value. That's our solution. So the correct answer for this one is going to be letter C. It is positive 2. Now, just to show you the other method you could use, if you just type it out. Okay, let me just come back. Okay, right here, it's easily clickable. It's 2, 0. We get a vertical line. Okay, the answer is 2. And you could also solve this using regression. What you would do is you have to make the x's, every x into an x1, and you replace the equals with a tilde. Right there, x1 equals 2. That's your answer. So for this, a problem like this, there's really not much difference in terms of one method versus the other. It's kind of personal preference. All right, let's look at the next problem now, number 15. Okay, so first I'm going to show method 2. Again, remember you type SQRT to get a blank square root. Okay, now this one, notice I can't click on it. It's not telling me what the value is. Now if you zoom in here, you can pretty clearly see that it's 8 and the answer is 8, but you don't know with 100% certainty because you can't click on it. So that's why I don't like this method for the radical equations, rational equations, the ones that basically are not clickable. So instead, I would probably use method 1. Actually, just while I'm here, I've already got it typed in. Let's put that back. Okay. Let's just instead do regression first. So notice right here, it gives me x1 equals 8. Okay. There's my answer. Correct answer is letter A. Now, let's do the graphing method. So let's get rid of all this. So there's the first one. And we're looking for 1 plus square root x plus 1. Okay, so we can clearly see here, this is the intersection point. It's 8, 4. The x value is 8. Therefore, that is our answer. Okay, so that's how you could do that using all three methods. Now for 16, this one, I'm not going to show all three methods. Instead, I am going to show regression and show that I get x1 equals 5. So the correct answer for number 16 is letter D, 5. This is a rational equation. We've got x's in the denominators. You can just type the exact same thing that you see in Desmos, just change the x's to x1s, and replace the equal sign with a tilde, and that's it. Don't need to bother, doing anything else. All right, let's go to the next page. So for a quadratic. Now, this one it's going to be a little bit trickier. But we can still do it quite easily in Desmos. So what I'm going to do is, and I'll also mention about an alternate solution method you can technically use for this as well. I'm going to use regression. Actually, no, I changed my mind. I'm going to use let's try graphing. Let's see what we get when we graph it, and then maybe we'll use regression if needed. Okay, so here are two quadratics. We can see they intersect basically at this point and at this point. So all we're concerned about is the x value. Okay, those are our two solutions. So I'm just going to export those points. Click on the point, and then you click this little button to export the values over. All right, so now I'm looking for matching one of these expressions. Okay, so the question is, which one, matches this? So I'm going to start just typing in the first one. Okay, so we got -5 plus this. So notice, does this match one of them? It looks like it does, right? It looks pretty close. It's -0.5527, blah, blah. And it looks like it matches, this second one here. So that's probably going to be the answer. But let's just double check here. Actually, no. I just realized something. I didn't read this question carefully. It says, what is the smallest solution? So which of these two is smaller? Obviously, -1.447. So we get rid of that. We're looking for matching only this number. So this first one is incorrect. Now, if we do this one, notice it matches right here, -1.44721. So this is going to be the correct answer. It's letter B. C and D, you can check them, but they're automatically going to be ruled out because if I change this -5 to a positive in front, it's automatically going to make the numbers larger, right? And we already know that we want the smallest solution, which is right here, -1.44. So C and D are both not going to work. You don't need to check them, but you could just to be safe. So this is what you do with the graphing method. I'll just show you for this one, for the regression method, the problem is that without knowing, what the graph looks like, or without doing any other work. Okay, so you do this and you get an answer. The problem is you don't know if that's the smallest solution or not. Okay, you have to put in a constraint or a restriction to see if it is. So let's say I make it less than -1. Okay, so notice here it gives me another value, and the other key thing is that this RMSE value is 0. That means that this is a solution, that the regression is working perfectly. The root mean squared error is 0. That's what you're looking for. Okay, if I tried to go the other direction, like Let me see if I can get it back to the, yeah, so like if I try to go the other direction to see if there's one on the positive side, see, notice the RMSE is not 0, and like the x1 is like some weird random, ridiculously small value. And if I keep going here, notice the RMSE keeps getting larger and larger. So that tells me that there's no positive solution, that the other solution has to be, in the opposite direction. So you could do it using this method and then type them in, but the reason I don't like this method for quadratics is because it is difficult to tell sometimes because it only gives you one answer and you don't know what direction you have to check to find the other one. Okay, so that's the only downside to using regression for a quadratic where there's multiple potential answers. All right, so now let's talk. One other shortcut thing you can do with quadratics too is you could pull everything over to one side. Okay, and then graph this, and then your solutions are your two x-intercepts here. So notice I get the same x-intercept, same x values here as I did for the other one. It's just the y value is now 0. So again, we're looking to see which one equals negative 1.4472. But again, what you would have to do is you have to take the original equation, move everything over to one side, so it's like y equals everything else on the other side, and then graph it from there and look for the x-intercepts. All right, let's look at an exponential equation. So this one, let's try graphing it, or let's try doing just type the equation method. By the way, another hint too, when you're typing exponents for things, like if I tried to type, so I have 4 here, right? Let me get rid of this. Okay, so I have 4, and then I do the exponent. And then I try to type 2x plus. Notice the plus automatically sends me down there. You have to remember that. So what I have to do is, like, if I wanted to type it out, I would do this, and I would type the plus 2 first, and then go in the front and do 2x plus 2. Okay, which of the following is a solution? So notice it gives me vertical lines here, but they're not clickable. Now I can see one of them goes through 2. The other one goes through negative something, but I don't know exactly what it is. I mean, I guess by process of elimination, I could determine that it's b. It's obviously not negative 2. You know what I'm saying? There's no line over here. But this is another one where I would probably use regression. And notice its default is giving me x1 equals negative, and I could click this, it's negative 2/3. Okay, so there's my answer. It's letter B. If you wanted to try to see if there's a positive answer, of course, you could, like, make it greater than 0. So notice there is a positive answer. It's positive 2, but that's not one of our answer choices. Okay, so that doesn't help us. That doesn't do anything for us. All right, next let's look at a logarithmic equation. So here we have problem number 19. We have this question. So remember, for log, and then we hold shift and underline to get down here for the base. Base 5 of 1/25th. And notice this is equal to x. You don't even need to technically here like type tilde x1. Notice it's automatically evaluating, just giving you the answer, right? Negative 2. But you could do that if you wanted to. So the answer to this is negative 2. It's letter A, and that's it. It'll just find the value for you with not doing anything else. One other type of equation I want to talk about that's very useful to use regression on is Pythagorean theorem. So if you look at this problem, number 20, you have a right triangle. They tell you the hypotenuse is 25. They tell you one leg is 7. What's the other leg? So we've got 7 squared plus b squared tilde 25 squared. And that's it. The value is 24. You don't need to do any other work. You don't need to like square both numbers and then subtract them over and then take the square root of that and then possibly simplify that square root or anything. That's it. So the answer is 24. It's letter D. All right, so let's now go back to the guide and talk about one final thing as part of these core skills, and that is translations or shifts of graphs. So basically, you can take a function, type it in, And then you can find a new function which is translated or shifted from that original function by just defining the new function as the original function and then with the shift added into it. So what I mean by that is you type your original function, and then we type our new function, and let's say we want to shift it 2 units to the right. Okay, so notice here it shifted 2 units to the right, right? That's why I put a -2 inside. Or if I want to go 2 units to the left, or if I wanted to go up 7 units, put a +7 outside, or -7 units. Okay, notice it'll give you the graph. It doesn't give you technically the new equation of the function, but it does give you the graph of it. Okay, so let's look at an example problem related to this now. So it's question number 21. Basically, they give you this original function. It's shifted left 3 units, down 6 units, okay? And they want to know what's the equation of this new function after those translations. So what I would do is, now, of course, if you know how to do this in your head and just look at it and figure it out, like that's fine. You don't need to use Desmos, but this is just showing you how you can use Desmos if you want to. Okay, so g of x, we're going to take f of x and we're going to shift it to the left 3 units. We're going to do a +3. Then we're going to go down 6 units, okay? So after I do these translations, this is what the new function looks like. So now all I need to do is just go through the answer choices and see which one of these matches. Now this is technically covered in a separate skill about matching equivalent expressions. That'll be covered in a lot more detail in a separate part, basically in the intermediate skills video, but still just showing it now to basically show you how you would match the function after the translation to the possible answer choices. So notice here, for answer choice A, this graph does not match my g of x purple graph after these various shifts. Okay, so that's incorrect. So now let's look at answer choice B. It still doesn't match. It looks like vertically everything is good, but it's shifted in the wrong direction horizontally. So now let's try answer choice C. Okay, notice this overlaps completely. I turn this off, I see the purple. I turn it on, I don't see the purple. So that tells me that this is the correct answer. Okay, so correct answer for this one is letter C. And again, what I did is I graphed the original function, then I translated it, and then I just typed the answer choices to see which one matched it completely. I hope you enjoyed this ACT math related video. If you did, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Also, if you're looking for more practice in improving your ACT math score, please check out my course, Improve Your ACT Math Score, on both Teachable and Udemy. There are direct links to the course on both sites listed in the description and pinned comment of the video. Otherwise, good luck as you're preparing for the ACT math test.